All right, everybody, welcome to the Screencast. Today I'm just going to go through the scientific notation notes that you may or may not have seen, depending if you were in class or not. So let's get to it. So scientific notation is basically a way that we can take a look at a number that's really big, like we're seeing up here, and write it in a abbreviated form. So sometimes when we have really big numbers, such as this measurement of the size of the Milky Way in kilometers, you may not want to write all those zeros out. So what we do as scientists is we can abbreviate what that amount of miles or kilometers is using a notation that we call scientific notation. So what you would do here is to write this number. I see that if I look at all of these zeros, those zeros, there is approximately 3, 6, 9, 12, 15, 18 zeros. And my comma currently resides at the end of this number, though it's not written explicitly. So what a scientist might do is say, okay, well, this number is something like 1.00 times 10 to the 18th power. Meaning, if I took the number 1 and multiplied it by 10 18 times, I would end up with this really large number. Okay, so it's a good shorthand to write numbers this way so that we don't have to write all these zeros in chemistry. We're going to use a number second semester especially called Avogadro's number, which is a number that is to the 23rd power. So we're going to need to know how to write in scientific notation, as a lot of our answers when we're dealing with things like particles and atoms are going to be very large quantities. Okay, so again, a positive number with a negative exponent is not negative. Only a negative sign in front of the number makes it negative. This is an important key. So as we're looking at numbers in these forms, just make sure you pay attention to that idea. So for instance, this 8.47 times 10 to the negative 9th, okay? This is not a negative number because if we see it in its numerical, or what we call decimal form in this class, you can see that it's still a positive integer. It just has a lot of zeros in front of it, meaning it's very small, okay? So how do I use scientific notation? So I think of it this way. There's two kind of conversions you're going to have to do. The first set of conversions is you're going to have to go from decimal form into scientific notation. So going from a number like this that has decimals in it and no exponent into this scientific notation format, where we see a number multiplied by 10 to the some sort of power. So just a few rules to go through and a few examples to kind of illuminate how we're going to do this. So let's say I give you a number in decimal form. I'm going to use a different number than I gave you in the previous example. So I'm going to use the number of 0.000256. Okay, so this is a very small number, and I want to make the equivalent number in scientific notation. Okay, so what I'm going to do is I'm going to use this chart to show you how I do that. So looking at the number 0.000256, I see that the size of the number in decimal form is less than 1. What that means is that the exponent sign is going to be negative, so it's going to be a really small number. Now what we need to do is decide how we're going to write this first part of scientific notation, because the first part is some sort of number between 1 and 10. Okay, so the number has to be between 1 and 10. That is the first rule. So maybe write this up here. First number between 1 and 10. Okay, so this part of the scientific notation format has to be between 1 and 10. In reality, it's more like 9.999, meaning that this first number that we write before the times 10 to the can't be greater than 10. Okay, so what we're going to do is we're going to say, okay, if I want this first number to be between 1 and 10, that means I'm going to have to take this decimal right here and move it between the 2 and the 5. Okay, and then when I do that, right, in my scientific notation number, that will be 2.56. Okay, so then as we look at that, that is great. Now we got to do the times 10 to the. So times 10 to the means, well, now we have to figure out, okay, we know that the number in decimal form is less than 1, so my exponent sign is negative, and we have to figure out how many hops I took, okay? So to do that and to move this decimal, I went 1, 2, 3, 4 hops. So this is going to be a negative 4. So that exponent number up here is telling us how many decimal places we had to move over. okay? So notice how this number is not negative, it's just to the negative power. And this is a really small number, so that's what that means. Let's go the other way. So let's say I give you a big number, 25,640, okay? What we're gonna do is we're gonna take our decimal, right? And the first thing what we're gonna analyze using this chart is the size of the number in decimal form. Well, I see the size of the number is way greater than 10, which means that the exponent sign is going to end up being positive in this time tens to the part in the scientific notation. So I'm going to have some sort of positive exponent, so I can figure that out right away. All right, so the decimal is not seen, but it's technically at the end of this number right now. So what I'm going to do is I'm going to take this decimal and I'm going to move it so that it can be the number in scientific notation could be between 1 and 10. That means that this decimal has to go between the 2 and the 5 again, and I'm going to count back 1, 2, 3, 4 spots. Okay, so this time I'm going to have a positive 4, and that first number is going to be 2.56. Okay, so just going the other way. All right, so that's how you go from decimal form to scientific notation. Let's go from scientific notation into decimal form. So let's do an example. An example here would be something like the number 8.43 times 10 to the negative third. So notice that my first number in the scientific notation is still between 1 and 10, right? And I now have the exponent here. So for this one, you kind of just follow what the exponent tells you to do. So if we start in scientific notation and we want to get into decimal form, we got to look at the sign on the exponent. So I see that the sign on this exponent is negative 3. So I have a negative exponent. That means the decimal is going to be moved to the left to give me something that is in decimal form. So the number of hops I take or the number of moves I take is related to the exponent's number. So what I'm going to do is I'm going to go 1, 2, 3 spots over. So when I do this, I draw these little kind of cradles, and in each empty cradle, you put a 0. Then the decimal ends up at the end of your last cradle. So what I will see is the new number in decimal form is going to be 0.00843. Notice how I can take the number in decimal form and I can also put it back into scientific notation if I want using this top chart. Okay, so if I were to put 0.00843 into scientific notation, right, I can follow this rule that it's less than 1. So that means my exponent would be negative, which I see here. I would have to move this 1, 2, 3 spots over, giving me that negative 3, and my first number would be 8.43. Questions so far? Okay, so here's what we're going to do. Let's do another example. Let's go the other way. So if I have 8430 times 10 to the third, okay? How would I write this in scientific notation, right? So what I have here, and I'm going to put a decimal, so I'm going to make it 8.430 to make it between 1 and 10, is if I want to do this times 10 to the third, what I have here is I have a positive exponent. That means I'm going to move my decimal to the right 3 spots, and I'm going to get a really large number. So let's go ahead and do that. So I'm going to move my decimal 1, 2, 3 using that cradle trick. So my new decimal will be at the end of this number. So that gives me the number of 8,430. All right, let's do some practice problems, and then we will let you check your answers by giving you a little pause in this video. So the first practice problem, we're going to be converting each of these decimal form numbers into scientific notation. So on the side here, I have a series of steps that I take every time I approach a problem, and it's kind of modeling how I'd use the charts above that I showed you. So the first thing is that I notice I'm in decimal form, and one of the things I'm going to do is I'm going to look, okay, which way am I going to have to move my decimal, okay? So over here, I know that I have to move my decimal to the right, putting it between the 3, 5, and the 6, okay? So I know my first number should be 3.56. Now what I'm going to do is I am going to look at if I'm positive or minus. So that means that I can look at what I have up here in my charts. So I know that if I'm in decimal form and I want to go into scientific notation, if my number is less than 1 in decimal form, that means the sign in front of my exponent is going to be negative. So looking at this number, I do see that it is indeed less than 1, which means that I am going to go ahead and put a negative here. Okay, so that's going to be a negative number. Now, how many hops did I take to get my new decimal? I'm going to go 1, 2, 3, 4. That means I made 4 hops, which means that my new number here is going to be to the negative 4th power. Okay. So that is number 1. Let's do number 2 together, and then I will let you have some time in this video to try one on your own and check your answer. All right, so this next one, I notice which way am I going to move my decimal. I'm going to move it to the left, so I can put it between the 1 and the 4 to make my first number between 1 and 10. Then what I'm going to do is I'm going to write down all of this digits afterwards for now. So 1.445, and we're just going to stop at this decimal for now. We're going to learn that these zeros are what are called insignificant zeros or placeholders. More on that later, okay? So don't include them for now. So that's 1.445 times 10 to the something. So what I need to figure out now is if this is going to be plus or minus. Well, I notice that this number is much bigger than 10 in decimal form. And so what that means is that this is going to end up being a positive exponent. So how many places do I have to move this decimal? Well, I started at the end here and I went 1, 2, 3, 4, 5, 6. So this is going to be times 10 to the 6th. Go ahead and try number 3 and number 4 on your own and come back when you're ready to check your answers. So pause this video. All right, we're welcome back. This answer should be 9.8 times 10 to the negative 3. So again, the reason why is we're going to put our decimal between the 9 and the 8. Which way did we go? We went to the right to move that there. All right, so that's how I know I had to go to the 9 and the 8. Is this plus or minus? Well, this number is less than 1, meaning it's going to be a negative exponent. Whoop. And then finally, we had to move 1, 2, 3 hops there, so that's why it's a negative 3 exponent. 7.906, you might have noticed something a little strange about this. It is already between the numbers 1 and 10, which is what we need for our first number for scientific notation. So for this, we're actually just going to write 7.906, and we want to keep this the same, okay? So if the number is already between 1 and 10, what we're going to do is we're going to put the sign or the exponent itself just to be 0. So I'm just going to multiply 7.906 times 10 to the 0. Because 10 to the 0, this just equals 1. So that just keeps the number the same. So if the number is already between 1 and 10, we don't need to really mess with it too much. Just multiply it by 10 to the 0 because we're already between 1 and 10. Okay, so for this rule up here, this decimal form number is already between 1 and 10, so it's 0. That's what our exponent would be. All right, let's convert to decimal form. So for this one we follow the exponent. Okay, so I'm going to write this 1.03 over here to give us some more room. So I see that is a negative 2. When I have a negative exponent, I go to the left. So let's move that decimal to the left. 1, 2 spots, open cradle, put the decimal after the last cradle. So this new number is 0.0103. Let's look at the number. Let's look at the next one. The next one is 8.317 times 10 to the 6th. Okay, so for this one, what we're going to do is I see a positive exponent. Positive exponent means we go to the right with our decimal. So 8.317, we're going to go 1, 2, 3, 4, 5, 6. 3 open cradles. Decimals at the after the last cradle. So this new number will be 8317123 zeros. All right, you go ahead and try. And then I'm going to post the answers to these ones after you're done trying. So pause this video and give it a go. So these were really big numbers, and so I hope this wasn't too crazy. Notice both of these are to the -8th power, so we're going to go to the left with these decimals. So what I would do if you're doing a homework, I would move your number all the way to the right to give yourself some space and start counting those cradles. So we're going to move to the left 8 spaces or 8 hops. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Then fill your empty cradles. And there we go. That is our new number. Okay. So it is a very, very, very small number. I can erase the cradles so you guys can see it more clearly. All right. Same thing over here. Same deal. When you do this, you can try this one on your own. This one will come out to be 1, 2, 3, 4, 5, 6, 7, 7, 5. Woo, that is a big one. All right, the last thing I'm going to show you in this video is how to use your calculator and how I would go ahead plugging things into your calculator in my class. In my class, you can use 2 different styles of calculator. You can use what's called the TI-30X, which is a triangle head. It's by Texas Instruments. It's pretty cheap on Amazon. And then there's also a TI-84. So any graphing calculator you might use for your math class, you can use in my class. So whether you're using either of these, when we're plugging things in with scientific notation on our calculator, it's really, really important that we utilize the right functions. So I'm going to pull up my own scientific calculator here. And so when you're typing into a calculator, you might feel really tempted to use this times 10 caret sort of function. But what we're going to do in my class is we're not going to use the times 10 button. Okay, this just screws up our order of operations. So we are going to use what's called the EE button. So this is basically a substitute for times 10 to the in scientific notation form. So for this one, it says if I want to put 5.07 times 10 to the 9th into my calculator, the way I can plug it in, at least on a TI-84, is I can go 5.07. So that's my first number between 1 and 10. And instead of doing times 10 to the, I am going to press the EE button. So on the TI-84, the button is second, and you're going to press the comma button, and you should see some sort of E appear, whether it's uppercase or lowercase. In my case, it's going to turn uppercase once I put the exponent name in, and then I'm immediately going to follow that with my number of my exponent. In this case, it's 9. So this 5.07 E9 means the exact same thing as this. Okay, so wherever you see E, that's just saying times 10 to the. Okay, so again, on the TI-84, that's what it looks like. On the TI-30X, make sure you're pressing the X to the -1 button. Okay, so second X to the -1, and you should see something similar. All right, so for number 11, I'm going to show you how to do this. And then the last tip before we do number 11 is to always use parentheses. So on my examples here, you're going to see parentheses around everything. I suggest whenever you put a number into scientific notation that you put some parentheses around it. Okay. So here we go. 1.46 times 10 to the 5th. I'm going to do this example with you, and then I will let you guys try the rest on your own for home fun. And I will put it at the end of this video in case you want to look at it after I pause. Okay. So for 11, 1.46 times 10 to the 5th divided by 1.46 times 10 to the 7th. What you can go ahead and do is let's throw that into parentheses. So I'm going to go 1.46. Second, comma, 5, close the parentheses or else you're going to get a syntax error. Whenever you see a slash, that means divide. Okay, so on this calculator, it even shows it as a slash as well. And then I'm going to plug in my other number. So we're going to go second, E7, and boom. That spits out the number of 0.01, which is what you should get if you plugged in your answer or your numbers correctly. So here it says to put your answer in scientific notation, which is something I'll ask you to do on future homework assignments. So 0.01, okay, I see that that number in decimal form is less than 1, which means that my exponent should be negative. So I want my new decimal to be after the 1 here. So it's just going to be 1 times 10, and how many hops that take? 1, 2. Since my number is less than 1, it's going to be a negative exponent. We're going to go -2. All right. Cool. I'm going to skip down and actually show you 13. This is really, really important. On your calculators, when you plug something like this in, what I want to make sure that you do is you actually utilize the negative function instead of the minus function. So for this one, 9 times 10 to the negative 1, you would plug that in as normal to begin with, so 9 EE, so EE button. And instead of doing a minus sign, you might be tempted to use a minus sign, you should look on your calculator for your negative sign in parentheses, which is usually towards the bottom near the enter button. And you should enter the negative 1 that way. Okay. Then you're going to multiply that by the next number, so 3 second EE 10. Notice how there's no tens, there's no multiplication signs within the scientific notation. And then you should get that answer of 2.7 E10, which just means the same as 2.7 times 10 to the 10th. All right. So for the other ones, I'm going to pause here, and then I'm just going to go over what the answers are and see if you got it right. All right, so if you did this correctly, this one should have come out to be 2.4675 times 10 to the 23rd. Now, that's a lot of digits. We'll learn in the significant figures lesson what to do with those digits and where to cut off and round them. And for this one, we should have gotten 8.39 times 10 to the third. Hope this was helpful. Thank you very much. See you guys later.